Right. Hello, everyone. My name is Ciro Continisio. I'm a technical evangelist at Unity Technologies. Today, I'm going to talk about timeline. I'm going to talk to you about how timeline is a very cool tool, in my opinion. It's really useful for sequencing much more than just animation, much more than sound, and the usual thing that you would expect from such a tool. And maybe sometimes even for the way we promote it, right? We promote it as a sequencing tool, but it can be more than that. So Timeline was introduced in 2017.1, and it's come a long way since then. It's now a package, so if you're upgrading Unity, you might see that sometimes some assets are asking for the Timeline package, and you need to install it. Packages are this way that we deliver features now, so we are packaging them all into isolated chunks, and then you can decide which ones to pull into your project. With Timeline, we powered several Unity short movies like Adam, Book of the Dead, The Heretic, and the latest one, Sherman, which is a animation fully rendered in Unity. And these are all the internal projects that we made. Then, of course, people are using it to do their own stuff. And with Timeline, you can, as I said before, you can sequence many things. You can sequence animation, you can sequence sounds, video, camera shots through Cinemachine. You can sequence other timelines, and then more, especially through the use of custom clips, and that's going to be the focus of my talk. So when we look at tracks in Timeline, just to give you a quick recap, has any of you used a Timeline right now? Okay, so some of you. When we look at a track in Timeline, of course it looks very similar to similar software like Premiere or After Effects, maybe more Premiere or Final Cut, but there are some differences. So the track looks like this. On the left, you will see what is called the binding. So each track, not all tracks, but many types of track support this thing which is called the binding, which is basically the object that track takes control of. So in this case, this is an animation track, and you see that in the binding, it's a game object that has an animator. So the animation track is going to take control of that animator and is going to move it around. And then how does it move it around? It moves it around through clips. So clips are the unit of Timeline. So you can have multiple clips on one track, as you see here. Here you have two animation clips, of course. So you see the name of the animation that we're using. And then you can have blends. And blends are simply like two clips that overlap each other. And when you overlap these clips, Timeline will automatically blend between them, depending on the type of track. So if it's an animation, it will blend between two animations, which means position and rotation. If it's a Cinemachine track, it will blend between the two shots, so the camera will actually move between the two positions. And then if it's a custom track, it's up to you. So you can define what does that blend, what that blend does. So why is the component that plays the timeline called Playable Director? Where does this name come from? I just want to give you some fundamentals on timeline. It's called Playable Director because Timeline relies on this thing called the Playables API. The Playables API is a set of API which provides a way to organize and evaluate data sources in a tree-like structure, which is called the playable graph. So you have this graph, and the data that goes through the graph, which, for example, for an animation is the position and the rotation of the bones and of the character, the data that travels through the graph is transformed at each node. And Timeline actually uses this underlying system to work. So the Playables API is the foundation of many systems in Unity, including the animator component and the controller, including Timeline itself, and including the new runtime rigging package, which I'm not going to show here. So they all use the playable graph to modify the data. And it looks like this. Basically, the idea is that you have this block, which is a playable, and the name says it all. It's playable because you can play it. So it has an inherent concept of time. So it has a start, it has an end, and you can play it through time. And as you play it, the playable is evaluated, and it will give an output, a value. Again, if it's an animation, it will be a position. If it's a custom one, it could be like the brightness of a light. So you evaluate it, and then you send this thing through an output. Sometimes you have multiple playables, and they go through a mixer playable. So it's another type of playable, special one if you want, which takes both inputs, mixes them together according to their weight, and that's why you see the two lines. There's one that's black and one that's gray. because the one at the top has weight 1 if you want. So the mixer takes them, processes the values, and spits out a third value, which is an output. And that goes on, right? The graph can go on for a while like this. So for instance, in the case of an animator component, it looks something like this. You have 2 animation states, and then they are processed, because sometimes they're blended between themselves. They're processed by a layer. The characters can have different layers. You can layer animations on top of each other. Then each layer can have multiple inputs. They are processed, they're blended, and they're spit out. And if you have multiple layers, that goes on, right? And then you have another layer that comes from here, and there's another thing that blends them together and then creates the final animation output. And the source of data, you see those 2 icons are not the best icon, I guess, but the animation clips that you have in your project. So they're the source of data. In the case of an audio track on timeline, similar concept. The track has a mixer, and then you can have multiple clips. And the clips, they take the source of data from the audio clips that can be in your project, so the SFX or the music, sounds, whatever. They're blended, mixed, and the output is given to timeline, and then timeline can either output or it can control an audio source component. So playables in a graph are evaluated each graphics frame. The output values, which are modulated according to their weight, as I said. And then the cool thing is that through this API, you can create new playables, and you can add them to the graph in different points, such as a classic example is custom clips for your timeline. And through the API, you also have these events that you can hook into to control how these custom clips work. So you have on behavior play, on behavior pause, on process frame, which is kind of like your update loop. And then inside that, you can do whatever you want with the data you have. To visualize the playable graph, there's actually a tool that we have, which used to reside on, first it was on Bitbucket, then it was on the asset store, but now that tool has also been made a package, so you can find it in the package manager, which more and more is becoming the centralized place where we put all of our tools. So this is called the Playable Graph Visualizer. And if you download it, you will be able to visualize graphs in your scene like this. You can see that there at the top left corner, you see that I'm visualizing a specific graph, which I can't really read the name. But this is a character. So this basically, this is the animator state machine of a character. And as you see here, I have the animation clip. Actually, I think I have a zoom in. Animation clip, which is one of the inputs. And then they go and they get processed until you get the animation output, which is here. And you see that the graph visualizer allows you to inspect what's happening to all of these playables, what time they are on, what's their weight, what's their duration, and so forth. It's a very handy tool to debug things. In the case of the timeline, this is how it looks like. So you see that you have the clips on the right. There are the endpoints, the endpoint playables. And then they flow into the mixers, which are usually the tracks. So each track will mix all of its clips. And then they flow into the main timeline, and they output the main, the value, the final value. So with this little foundation knowledge that I gave you, now I want to jump into some more practical examples. And I have three projects, actually, that I made in time, and I put them together in this presentation to give you a kind of like an overview of the different possibilities that you can have with timeline when you create your custom tracks. So the first one is to listen to input, and I'm just gonna jump straight away into the demo. So I need to do this. So let's see this example. This is basically like an RTS game, but I built some timelines into it. So the first one is literally like a cutscene. So if I press play, I do this. So you see the timeline, and you see here the timeline has stopped. And basically, it stopped because I have these custom clips. And these custom clips, I'm using them for dialogue. So I created this custom track here, which has these clips, and the clips, you see, they have some data here, and specifically, of course, is the data for the dialogue. So I store the name of the character that's talking, what they're saying, and the size of the text, and then I store a bool which says if it has to pause or not. And in this case, if I press the space bar, you will see the marker here will start moving again. And then it doesn't stop at this dialogue, and it stops again on this one. So it gives me the time to read the text. And I press space bar, and I have another stop, and I can read the text again, and then when I release, it goes on. So this is a very handy way of creating like a dialogue system for cutscenes, because then you can, I mean, it's a very stupid animation, don't judge me for that. I'm not a filmmaker. But this is a very handy way to create a tool that then you can give to your designers, to your storytellers, or whatever they're calling your team, and then they can use them repeatedly to basically output many cutscenes and a lot of content. And so I'm going to show you how these things look like. And I don't want to dive too much into the code, because I think showing code is always hard in presentations, but I want to just give you an idea. I think it's this one, actually. No, dialogue. So you see that here I have several classes that define what the code does. And you actually need, depending on what you're doing, you might need from 2 to 4. The main ones you wanna have is definitely the one that defines the track. And the one that defines the track is usually very simple. It's basically telling Unity what type of track we're talking about. It tells which type of clips this track accepts. And then it can say what color it is. And that's the color that you see. Let me show you the timeline again. It's the color that you see here at the bottom and here on the left. So this track is white, just to tell them from each other. So this is the dialogue track. Then you have the dialogue clip, which is usually is the data, is the piece of data. So each clip is a piece of data and contains the values that, in this case, you will see here in the inspector. And then you have another thing which is called the behavior, and I mentioned it before when I said that it has the events, right, on behavior start, on process frame, and that's what it looks like. And on behavior, for example, on playable create, I do some things. On process frame, can you read the code? Let me make it bigger. So on process frame, you see that this one, for example, looks at whether the clip has been played already. It checks its weight, and checking the weight just basically says, is the playhead on the clip? Because if the playhead is not on the clip, the weight is 0, and when it goes on the clip, the weight is 1. And then when two clips are blending, the weight, of course, goes from like 0 to 1 or from 1 to 0. So in this case, this particular this particular track doesn't blend. I didn't build any blending mechanism, because for me, it doesn't make sense. If I have two dialogues and I'm going to blend into each other, it's either one or the other. So I really didn't care about, I really didn't care about blending. So I'm just saying, like, if it's above 0, I need to play this text. And as you can see, I call some kind of singleton that handles the UI. Some of you might not like singletons. I'm sorry for that. It's fine. This is my presentation. It's just an example. And I pass to the UI all the data that comes from the clip. So the character name, the dialogue line, and the size of the text. And then the UI does its thing. So timeline is just telling the timing and the data, and then the UI is doing the rest, of course, which is a good separation of concerns, if you want. And then here I have a little check that checks if the application is playing. If the clip asks me to pause, then I schedule a pause, and I have a whole system to deal with that. So you see here on behavior pause means when the clip is finished. So I'm able to say how much the dialogue lasts, and then when timeline exits the clip, if that clip has to pause, timeline will pause. And so through that, I can say, I can go to this. I have so many Unities open. I can go to this interface here, and I can decide that this text, appears here, and then when it gets here, it will pause. So I can time how much screen time that text has. And then if I have this enabled, the bool, it will pause. Otherwise, it will just move on. And that's what I do here at the center, because this is just a scream. So this timeline is now off. That's why it doesn't play. But this is just a scream, so it goes like, oh, Elizabeth, and then you don't really need to read this. So I skip it, and then I pause here. Right? So it's a flexible tool to give a little bit of control to the artist that's creating the timeline. OK, so this is for the dialogue track. So in this case, I lost my presentation. Too many virtual screens. In this case, you have a situation where the game controls are passing the input to the timeline, and then as a result, the timeline is controlling the playback. So the timeline stops or keeps moving. Very, very simple example. So when I was developing these examples, I was thinking, is timeline just a linear sequencing tool for cutscenes, or can I play with timeline a little bit and make it and bend it somehow? And I came up with the idea of creating some custom clip to create non-linear timelines. So a timeline that doesn't just play from start to finish, but that can wrap on itself, which is a very trivial thing. I'm not saying that I invented anything new, don't get me wrong. So in this case, I steal this demo here. I lost my mouse. OK. Play again. So in this game, I have, I didn't show you, but like if I press 0, you can see that this is actually a fully fledged RTS, which took me almost a week to build. And you see the units can fight each other. I can send them to a specific position in space. I can send them here. They will go as a group, and they use the nav mesh to navigate around. I have a whole cinemachine thing to like move around the camera. So it's kind of like a vertical slice of a game, if you want, very, very simplified. So non-linear timeline. So I built this one. So you have this little intro. You see these two monsters, and there's a storm that starts. And now I actually have control again. So you can see that now I can move the camera, and I can play the game. And the storm is going on. And if you check the timeline for this thing, it looks like this. And you will notice that when the cursor gets to this point here, it jumps back. So here I have a timeline that basically has an intro here. And you saw those like camera shots when the camera is like looking at the enemies and zooming in, then moving to the other one, and then going back to the gameplay. So this is the intro. Then I have a central body in this timeline, which is going to loop endlessly. And then I have an outro, which is going to play at some point. So the key thing here is this track here that I call time machine track. And the idea here is these clips have the ability to act as kind of like a marker, if you want. And this one, for example, acts as a jump to marker. So this clip will jump back to the previous marker if a condition is verified. And this part here is a bit hard-coded to my game. So this is not a generic tool. This is hard-coded to my type of game, which is an RTS. So I hard-coded it into a system that tells me whether a certain group of units is alive or not. So this thing evaluates the condition. If it's alive, it jumps back. As soon as they die, it goes forward. So basically here I'm able to sequence this whole like storm, and you see the rain is going on, and I want to fight these enemies, which are my boss fight. So my troops will start attacking, hopefully they'll win. And you see that as soon as they die, next time the marker hits here, I see the end of the cutscene. And you see the storm ends, and then gameplay resumes again. So I think this is a cool way of creating something that has stages. It doesn't necessarily need to be a fight or something like that, but it's something that you can give it to your artists, and they can, create some narrative, but then put some kind of like stopping points and go like, is this thing happening? If so, I go here. If not, I go this other way, or I just proceed with the timeline. And you might be thinking, like, I can build a dialogue system with this, like with multiple choices. I wouldn't suggest that. So my suggestion here is just that as you do this thing, this timeline is very, very simple. It only has one point where it wraps back. if you were to build some kind of multiple branching dialogue system, you would probably get confused very, very quickly. And then you would have to rearrange things on timeline a lot. And at that point, you're losing the advantage of using the tool. So my suggestion is be careful with what you build with this stuff. Use it for something that's sensible, that makes sense, and not just like any branching thing. But for one jump like this, I think it makes total sense. You can check, if the character has an item, or if a door is locked, or if a monster is dead, or whatever condition in your game. And that's why I said, in my case, this is very much hard-coded. It's not a generic thing, but it taps into one of the systems. Something else to say about this? In terms of code, it's super simple. It literally asks the system whether the monsters are dead. And you see that here I have the monsters hooked in as a reference. So I have these scripts that I call platoon, which are basically just an array of enemies. So the timeline passes the array to the system. The system goes like, yeah, they're dead or not. It checks their health and replies with a Boolean. And then the timeline acts according to that. And jumping back to the previous point is as simple as setting the time on the timeline. So the marker just goes back and keeps playing. Whoops. All right, I'm lost again. So in this case, the idea is that the game logic is basically sending the game state to the timeline. And as a result, again, timeline produces playback. So playback is controlled by the game logic. And then I moved forward, and I thought, OK, I have an RTS. What can I do with this? Can I actually plug timeline into the game systems? Because what I did here was just like a simple check on the health of some enemies. But I have some game systems that are running all the time. Can I take advantage of those with timeline? So I came up with this third use case. It's called platoons. And basically, the idea here is I have this system, which is the AI of the game. And the AI of the game, every unit has several states. It can be idle. It can be moving. It can be attacking. They can have a target or not. And then as they attack, they will play an attacking animation in loop until they either die or their target dies. So there's a lot of stuff that this system is doing for me. And I thought, I want to choreograph a battle. Why do I need to put all the animation clips on timeline when I can just tap into my system? So in this case, for example, I have this timeline where these characters are moving with AI. And then through Cinemachine, I'm framing them as they move. And I don't necessarily know exactly where they're going to go. I just set the target, and they will move to that target. I have this camera shot where I see the army moving. It's very, very rough, I know. And then you have this final shot where the two armies are like clashing, and you have more monsters coming from the hills. And our army is overwhelmed. They're gonna die. So the way it works, if you see here at the bottom, I have this, again, a custom track, which is called AI command. And basically all that this track does, it has the conception of what AI commands are available. So you see here I have go to and guard, go to and idle, attack target, stop and die. And then depending on which one I select, I have some data. So if it's a go-to, it will have a position. If it's an attack, it will require a target. And so timeline, as it plays through these clips, it will go to the AI system. And you see here in the binding, I connected the platoon. So this one tells timeline who is going to act. And these ones, they tell what they're going to do. So if I show you the thing, it doesn't work. Because it's off. And then the thing I added, actually, so the funny thing here is, because I'm using the nav mesh, and the nav mesh is not active in edit mode, I couldn't really preview where the units would go. So I built some system that just, blends, lerps the initial position with the target position. So when you preview the timeline in edit mode, you will see the character going in like a straight line. Then they will do this, and then these ones will like actually move forward, so they look like pieces on a board, if you want. You can see here how they move in position, and then at some point they will attack basically when the editor is in play mode. But this was a very quick way to preview where they're gonna move. And as I said, this is kind of like it's like not 100% predictable if your game is not predictable. So if your game every time it happens is a bit random, then when you play this thing, every time it happens, it's going to be played slightly different. So that's up to you, the way these things interact, whether, so you might find some situation where one of the units actually doesn't die in time, and then they keep fighting, and then your cutscene is different. But that might be okay. It depends on your cutscene. Like sometimes you might want to have, for example, a battle in the background as some narrative happens in the foreground. So you're actually really just following your main protagonist, which maybe is animated in a traditional way, but then you use this system to drive the battle in the background so that you don't have to animate like 100 characters. And then maybe at the second time, somebody wants to move an object like a house at that specific point, and they want the battle to happen just slightly to the side. And in this system, it's super easy to just say, instead of going here, now you go there. And then the AI will calculate all the paths and move your units there. So the battle actually happens somewhere else. So this is very handy if you plan to have a lot of cutscenes and a lot of battles. When I was building this, I was thinking of, I don't know if you remember Warcraft 3. It had a lot of narrative happening at the end of the game, where you like deal the final blow, you kill the boss, and then it's like dialogue, but the battle is still going on around you. And I thought that would be a cool use for this kind of tool. So in this case, we have a different situation. In this case, it's not the game that controls the timeline, but it's the opposite. It's the playback of timeline that speaks with the game AI, and then the animation is actually produced by the AI. So it's not timeline that's driving the animation. Timeline is kind of like just requesting some animation. And then the AI is going to do the rest. It's a peculiar use of timeline. Then we have markers. And markers are a relatively new thing that came to timeline in 19.1. Do you know what markers are in timeline? No? Have you ever heard of, well, everybody was asking for them, the timeline events, right? That's what they were called. Sorry, that's what people were asking for. We didn't call them events because we have several events in Unity, and that would have created a lot of confusion. So the way they were implemented is, since 19.1, as I said, timeline has its own integrated marker solution. So they're markers, they're things that you put on timeline at specific points in time. And they are opposed to clips because markers are instantaneous. So where the clips have a start, a duration, and an ending, the markers are just like one point in time, and you're either before the marker or after the marker. And that's how they look like. You can see one here, which is where the time is, and then there's one here which is disabled, so you can actually mute them as well. And then on top of markers, so markers are just like a position on timeline. And you can actually, through your APIs, you can check if a marker exists or not, but they don't do much. And then on top of markers, you have this system which is called signals. So we provide one custom type of marker, which looks like this, and is basically what people were asking for, the event system. So signals are kind of like active markers that can emit a notification, and then a component can pick up that notification and act on it. And so in that component, you will connect like Unity actions, and then you can speak with different systems. And signals are shipped with Unity, so you don't need to create it yourself. For separating the concerns, signals have this peculiar structure where they have like 3 steps. So you have the emitter on the timeline, which is the one that emits the notification. Then you have an asset, which acts as kind of like the channel. So the signal can pick up which channel it wants to broadcast on. And then you have a third step, which is the one who receives. So that receiver will say, like, I want to listen to this channel and do this as a result. And so you have, animation on the arrows, which I should have played before. So you have the marker that sends the signal on the channel, and then the signal is received by a component. And I'm going to show you a practical example of this, which is here. So this is another type of game, again, that I built from scratch. It's kind of like a card-based game, similar to like Clash Royale. And I have some timeline at the beginning as a cutscene, and then I have the gameplay, and then I have some timeline at the end when you either win or lose. So I'm going to show you how it looks like. Full screen. So you have this cutscene at the beginning. These two kings like laugh at each other, and they generate some units, and then the units fight. And now I'm in gameplay mode, basically. Now I can play, and I can instantiate my units and have a fight, good old fight. And then you have this final timeline, which shows you the destruction of the tower, right? And then I can retry, and I see the intro again. It's a very, very small game. So you see here I'm in a timeline, and then I blend into gameplay. Now I'm playing, and then you blend again into the timeline. So to show you where markers are used here, let's check the timeline. So I have the intro one, which is here. As you can see, these are a bit more elaborate than the previous ones. So you see I have some cinemachine, which is camera shots. I have some animation on the two kings that plays here. I left the audio on. And then I have some sounds. And then the markers are here. So I want to show you this one first. So this one is a classic signal. And I'll be conscious of the time. It looks like this. So this one is saying, at this point in time, I'm going to broadcast on the, do you remember I said that signals are like channels? So I'm going to broadcast on the start match channel, and somebody's going to pick it up, and I don't know who's going to pick it up. But actually, here there's another object, which is called timeline signal relayer, which has the component that I mentioned before. So you see this one is listening to different channels, to game over cutscene, to camera shake, and to start match. And in this case, it's doing this action as a result. So when any timeline plays that marker that broadcasts on start channel, this object is going to find it, and is going to produce this action as a result. So it's going to speak again with the game manager, and it starts the match. And so the AI will start kicking in and playing cards and stuff like that. Another example is the, I don't know if you noticed, but when the final, the towers are distracted at the end, the camera shakes, and that thing is also an action that I send to cinemachine, and then cinemachine shakes the camera for a while. So in this case, actually I haven't spoken about custom markers. In this case, the markers notify, actually, yeah, I need to show you this example, sorry, I'm confusing myself. So one thing that you might have noticed is that at the beginning of the game, when the king gives the order to attack, you see two units spawn here. And basically what I've done is I've built a custom marker. So again, similar to the custom clips, right? I'm putting my gameplay inside the timeline. So in this case, because this is an instantaneous action, it makes very much sense to build it as a marker. And what this does is it kind of like plays a card very much like a player will do, but it does on the timeline. So you see here that I have, again, the data is what kind of card, where to play it on the battlefield, and which faction it belongs to. And then here I have another marker which does exactly the same in another position, but on the other faction. And because these two units are very weak, they will clash with each other and kill each other very quickly. And then the gameplay starts, and I can use my units and keep playing. So I use basically gameplay as a narrative tool, if you want. And this looks, I know that this looks very similar to the previous example, and that's because I did this one later on. Before, when markers were not available, I only had clips, and now I remade this thing as a marker. And I think it makes much more sense because this action is kind of instantaneous, so it makes more sense to have it as a marker rather than a clip. So in this case, whoops. In this case, again, we have another peculiar situation where marker has a notification to the game AI, and again, the game AI produces the gameplay. So it's similar to the previous one, as I said. 10 minutes left. So final example, and this is the one I like the most, is timeline as a game design tool. So until now, we talked about cutscenes, we talked about narrative, and blending it with the gameplay. But then I had this idea, and I wanted to actually verify if it was possible, whether it was a cool thing to do. So in this case, I basically decided to use timeline as kind of like a level design tool, if you want. So I thought of a game that was side-scroller shooter. In Japan, they're called danmaku. They're bullet hell shooters. So they're these games where you have enemies that shoot a lot of bullets, and they have predictable patterns. And the patterns are always the same. So you can literally, and you have to learn them, right? The game is super hard, and you need to find holes in those patterns of bullets. There's only maybe one spot where you can be without taking damage. And so you need to navigate as you shoot the enemy ships and stuff like that. So I was thinking, in these kind of games, everything always plays the same way. There's no AI. The enemies don't move according to what you do. They just do their own pattern, and they shoot bullets always in the same way. So it would be cool to have a tool that actually allows you to preview that. Imagine the pain of making a tool like that and writing everything in code, and then every time you need to play your game from start to finish to see that final part and how the patterns look like, and maybe you want to change it. So you go back and you change your code, and then you have to play the level again. So basically, I built a tool using timeline. And as you can see, let's take this one. I think I need to disable and re-enable this one. Actually, let me play the game first, just to give you an idea of what the game looks like. There's more things happening here. There's an UI that plays. There's some dialogue. I'll show you if I play it. I don't know why this one has a very long starting time. Yeah. So I'm playing the game, and you see the enemies are coming from the right. They're following a path, and I can kill them. They stop shooting, of course. You see, I have some score here. I can take damage from their bullets. The camera reacts to it and plays a sound effect.
No.
And I have some dialogue. Then I have some kind of like narrative section, right? When they speak, and then you have the asteroid field. And you can see the timeline here. So I'm using mega blocks, if you want. They're control tracks. They control other timelines. So you see I'm going through phase 1, then phase 2. And at the same time, I'm playing asteroid field, which is another timeline. And I'm going to go in another timeline, which is called the chase.
No,
Now I'm seeing from a different point of view, and I see these 3 spaceships, and they just pass by. So she's like, oh my god, what are they doing? Where are they going? And then I resume gameplay, right? And I'm again in another phase, which is much more complicated. So what I did was, if I open one of these phases, which are basically timelines themselves. Oops. You see here I have these clips, custom tracks again. They're called path walker clip. So the idea here is that every clip defines an object that will walk a path, and as it walks the path, it will shoot with a certain pattern. So I stored what object it is and what pattern it is into scriptable objects. I don't know if you're familiar with them. So you can see here that every clip has a path, has an object definition, and has a pattern definition. And so this way I can define different patterns and say many bullets, fast bullets, slow bullets. and then I can have this type of ship, this other type of ship, and I can combine them, and I can create a lot of variation on that. And then you see I have the animation curve here. So if I click that, I can actually edit the animation curve this way, and this is the path that the enemy is going to walk. So if you see, if I scroll the timeline manually, actually you can see it, maybe you can see it here. Can you see the thin purple line with the little dots? That's the curve. Unfortunately, this is a gizmo, so I can't really zoom in on the, sorry, I can't make the line thicker, but let me disable this. But I hope you see the curve. And basically, you will notice that this enemy, for instance, as I scroll through the timeline, he will walk the curve and shoot the bullets in the pattern that I defined. So it's kind of like programmatically shooting the bullets. It's procedural if you want. So nothing is driven by physics, but everything is always like hand-moved by timeline on these paths. And then the cool thing is I can go in here, and I can take this path, and in real time, I can modify the curve. And then you see the enemy moves up and down. So I can have an immediate feedback, and not only the enemy, but also actually, I think the bullets that he's shooting will move, you see? Because whenever I change the curve, timeline evaluates that clip again, that playable. You remember I spoke about that at the beginning. So he evaluates it again and reconstructs all that happened in the scene according to that. And so as you can see, I can layer like different enemies at the same time, and then spawn some more, and then put some extra stuff in. You know, this is not my, I mean, this is another custom track, but I can mix this gameplay with narrative and play with the asteroids, and the asteroids are also on this path, so I can have custom paths for the asteroid field and stuff like that. Yeah, so very cool, in my opinion, very cool use of timeline, because now I can check this thing, and I can say, you know, have a master timeline here, which is the one that I was playing before, where I composite all of the other timelines and I play them together. And then at any point, I can go to this master timeline, and here in the playable director, I can say, you know what, I want to start from second, let's say 100. And then when I press play, you see, it jumps to second 100. So it allows me to test the gameplay at that specific point in time. And now I'm in the middle of phase 3. Okay, so if I have to iterate over and over again over these kind of like levels or phases, whatever you want to call them, I can play them quickly and change that and test, change that and test. So for a game like this, timeline makes a lot of sense because this game is linear. So it always plays from A to B, and there's never any variation. So it makes a lot of sense to use timeline as a tool, even if normally you wouldn't use it for such a use. Okay. So in this case, again, what's happening behind the scene is that the game logic is actually controlled by timeline. So timeline controls the game logic, but it also controls instantiation of those enemies, the animation of those enemies, the gameplay, because when something is destroyed, timeline needs to know, and then it doesn't move it anymore. So it needs to have a concept of like what's actually alive and what not. And it moves the bullets and stuff like that. Actually, my bullets are, the collision is checked through physics. So not everything is done by timeline, but timeline receives the result of that collision, if you want. So I'm almost out of time. I have 1 minute. So final considerations. Well, use timeline with Cinemachine because they're a very good couple. Timeline, I think, is great for linear systems, as I said before. Try not to force it for systems that are inherently branching. So if something branches a lot, the time machine example that I did before breaks, you know, and then you're confused and you don't know why that thing is moving back. It's better to use other systems, maybe something custom that you want to make yourself. Don't be afraid of creating custom tracks and clips. They're a very good tool in the long run. So at the beginning, it might look like you're spending a lot of time creating them, but then if you're making cutscenes and storytelling over and over again, they will prove very useful. Watch out for the frame rate, because timeline, I didn't have time to explain this, but timeline is not like, you know, Premiere or Final Cut, where you have the concept of a frame, and you play all the frames, and you have 60 frames in a second, and that's it. In timeline, you don't know how many frames you have, because the game might run at 60 frames, it might run at 90 frames, or it might run at 20 frames if it runs very badly. So if you're asking timeline whether the time is exactly that moment, you're never going to have an answer. It's never going to be true. The time can be like slightly earlier or slightly later, depending on the frame rate. So when you code your custom tracks and clips, you need to think about that. You don't say, if seconds are 2, you say, if I'm past 2 seconds. Yeah, so don't check for exact timings, but rather like, are we past this time? Some resources. I don't know if you want to take a photo of that. So these are, you don't need to. This is a bunch of blog posts, the last 3, of which I wrote the first one. And they tell you, the first one tells you exactly how to start coding your custom clips. Again, I didn't want to do it here. It's pointless. But you can study it at home if you found this presentation interesting. And the other 2 talk about markers. And then and these are the assets that I've shown you. So if you want to look into my terrible code and you love singletons, you can download these assets and basically look at the solutions that I created. Of course, they're like sometimes specific to my case, so don't take them as a gospel. But that's the idea. And that's it from me. I don't have time for questions because I used all my available time. You can grab me. Sure, sorry. You can maybe grab me outside for a minute. Thank you.